This video, I'm going to go through the 2017 Mathematics Exam 2. That was the November exam. So I'll go from the extended response questions first, do the multi-choice questions later. Okay, so first question is 11 marks. We started from polynomial function x to the power 3 minus 5x. Part of the graph f is shown below. We want to find the coordinates of the turning points and then deal with the other parts. So if I define this function on the CAS calculator, and then if I define the derivative, if I wish, you can just press shift minus and get the derivative. Now to find the turning points, I'm going to use the solve button, curly bracket, y equals to f of x, comma, dfx equals to 0, comma, xy. So I'd be able to get, let's say, two pairs of coordinates in the exact form. Minus root 15 over 3, 10 root 15 over 9. And the other point is root 15 over 3 minus 10 root 15 over 9. Yep, that's the first one. And then we can take a look at the other parts. Next part, we want to find, let's say, the equation of the straight lines through point A and point B, where we have, let's say, the pair of coordinates, -1, f -1, and 1, f1. And the next thing is we want to find the distance AB. So I'm going to focus on the CAS calculator output here. So for example, I may say, okay, y minus, actually, I should say, let's find a gradient first. Gradient is f1, take away f -1, divided by 1 minus 1. So the gradient is -4. And then if you notice this line is going to cut through the origin, this will be much easier. Alternatively, just say y equals to -4x plus c, given that x equals to 1 and y equals to f1. So you see the c value is 0. So therefore, y equals to -4x, okay? And then to find the distance, I'm going to use the norm button, 1f1 in a square bracket, like a matrix, and a -1, comma, f -1. So you get a distance 2 root 17, okay? That's all you need. All right, so I'll say, okay, so that's how I would answer this question. And there were 2 marks, so the process of finding, let's say, the gradient is probably is 1 mark, and then determining the c value. And don't forget to state the equation, not just stopping at c equals to 0. And the distance AB equals to 1 take away -1 squared plus f of 1 take away f of -1 whole thing squared, okay? So under the square root, and then you will get the answer as required. Okay, so that is the First 5 marks. Then we move on. Now, you have another, let's say, function g of x, which is x to the power 3 minus kx. K is a positive real number. We have c and d. We want to find the distance cd, and then find the values of k such that distance cd is equal to k plus 1. Notice that the k is positive. Therefore, when you solve relevant equations, you need to embed that condition. Define g of x equals to x to the power 3 minus k times x. Don't forget to multiply the two letters, okay? If you just put kx, it doesn't recognize it's multiplication. Then we say, okay, norm 1g1 take away minus 1g minus 1. So you get that expression. And for the next part, when I solve that equation, equated to k plus 1. Okay, I'm able to get, let's say, two values. Both of them are positive, so I take both of them, okay? Because this is a CAS active exam, you don't have to really find the expressions for G1 and G minus 1. As long as you set up a correct calculation, you should be fine. So the answer is 2 root k squared minus 2k plus 2, okay? Then it says solve 2 root k squared minus 2k plus 2 equals to k plus 1 for k greater than 0. We have k equals to 1 or k equals to 7 over 3. Yep. And then the diagram below shows part of the graph G and y equals to x. These graphs intersect at a point A, A, and 0, 0. Find the value of A in terms of k, and find the area of the shaded region in terms of k. So basically, you need to find the A value first and set up a suitable definite integral. So we say solve G of A equals to A, A. So you get, let's say, minus root k plus 1 or root k plus 1, but A is greater than 0. So we say GA equals to A, or GX equals to X. The question wants the letter A, not X. So we say A equals to root k plus 1. Okay. And also we want to find the area of the shaded region. So the shaded region has the area equal to 0 to root k plus 1. And then we say x minus g of x, because that is the upper function, that is the lower function over the same domain restriction 0 to a. Don't drop out your dx, okay? And then you can just use your CAS to figure out the answer. So I would say the first question is very straightforward. It's just a matter of applying your CAS calculator appropriately. And eventually the answer is k plus 1 bracket squared divided by 4. Okay, so we can move on and look at the other question. Question 2 is concerning a Ferris wheel. Sammy visits a giant Ferris wheel. Sammy enters the capsule on the Ferris wheel, which is here above the ground. The Ferris wheel is rotating anti-clockwise, so in this direction. Movement. The capsule is attached to the Ferris wheel at a point P. The height of P above the ground, H, is modeled by H of T equals to 65 minus 55 cosine pi T over 15, where T is the time in minutes after Sammy enters the capsule. So we know that T has to be greater than or equal to 0. H is measured in meters. Sammy exits the capsule after one complete rotation of the Ferris wheel. So our domain T is less than or equal to some value here. That is the time to complete one rotation. So we can use the period. In this kind of circular function modeling, period equals to 2 pi over n, so pi over 15. That is like 30 minutes. Okay. So the domain restriction is supposed to be 0 to 30. Next thing is for one complete rotation, state the minimum and maximum height of P above the ground. So basically, the minimum height equals to 65. Middle minus 55 times 1. That is 10 meters. And the H max equals to 65 plus 55. That is 120 meters. For how much time is semi in the capsule? So that is the period equals to 30 minutes. Okay, next thing is we want to find the rate of change of H with respect to T, and hence state the value of T at which the rate of change is at its maximum. This time we're not calculating the maximum height because we already dealt with that. But I want to take the derivative and find the maximum derivative value. So on the calculator, I should go for Control Up, menu, insert the problem, and add a calculator. So this time I'm using H bracket T is assigned to 65 take away 55 cosine bracket, a fraction, pi times T divided by 50. And then I'll calculate the derivative, which is this guy. So you can see this is a positive cosine function. 11 pi over 3 sine of pi t divided by 50. And over one period from 0 to 30. This is the graph of the sine function, okay? Maximum is 11 pi over 3. The minimum is minus 11 pi over 3. That is the amplitude. And this is a quarter period. This is a half period, 3/4, and 1 period. So the maximum occurs at a quarter period. Maximum H dash of T occurs at a quarter period. Therefore, T equals to 30 divided by 4, which is 15 over 2. And the answer should be in minutes. Yep. And maximum H dash of T equals to 11 pi over 3. But I don't think that's required. It's just indicating, okay, this is H dash of T. This is 0. This is T. Okay. So that's 2 marks, or maybe 1 mark for this derivative, and 1 mark for the T value, the value of T. Okay, as the Ferris wheel rotates, a stationary point at B on the nearby river first becomes visible at a point P. Just notice, if you carefully compare these two diagrams, well, the lowest point of the capsule is like 10 meters above the ground. The highest is like 120 meters above the ground. When the capsule moves to the middle, that is like the center line. Okay, the center line is like 65 meters. So if you sort of match this diagram to this smaller one, I would say this point C is 65 meters above the ground. Therefore, it's 0.65. Okay, so you need to draw a connection between these two diagrams. And how about the radius of this Ferris wheel? Well, look at this diagram. Basically, it's like, okay, radius is 55, okay, 55 meters, right? That is the amplitude of the cosine function. According to the diagram, we want to find this theta, angle theta, and this point B is 500 meters away, so we can use the right angle trigonometry. Say tangent theta equals to 65, because from C to N is 65, divided by 500. And then we can find the theta value in degrees corrected to 2 decimal places. So I can just use my CAS calculator, trig tan inverse 65 over 500, or if you wish, you can divide everything by 5, like 13 divided by 100, etc., times 180 divided by pi, because I want the degree value. So the answer is 7.4069, which is rounded to 7.41 degrees, okay? And part of the partial P is given by y equals to root 3025 minus x squared plus 65. So this is a semicircle, I would say. If you define this function as f of x square root 3025, take away x squared plus 65. Okay, next thing is I'll take the derivative, and it's minus x divided by root 3025 minus x squared. Okay, so that is the answer. Notice that the question didn't ask for the domain restriction, but if you really want to specify the domain restriction, you might want to say minus 55 less than x less than 55, because at the two ends, the vertical gradients means undefined, okay? Okay. As the Ferris wheel continues to rotate, the bolt at B is no longer visible from the point P2 onwards. So after it reaches this point, from that, you are not able to see through the wheel and see the bolt B. The line through B and P2 is a tangent to the path of P, where angle OBP2 is alpha. So this is alpha. Find the gradient of the line segment P2B in terms of U, and hence find the coordinates of P2 corrected to decimal places. So the P2 is UV here. You might want to write it explicitly, say U, comma, square root 3025 minus U squared under the square root plus 65, okay? And this point B is like 500 and a 0, okay? So you can find a gradient of P2B. So we say V or root 3025 minus U squared plus 65 minus 0 divided by U minus 500, okay? So that is a gradient expression in terms of U. And then hence find the coordinates P2. So now if you have a gradient from 2 points, and these 2 points are along the tangent line, you can also say dy dx at x equals to U. That is minus U divided by square root 3025 minus U squared, okay? So these two expressions should be equal to each other because they represent the same gradient. Therefore, you have root 3025 minus U squared plus 65 divided by U minus 500 equals to minus U divided by square root 3025 minus U squared. Also, because we want to find a pair of coordinates, don't forget to say V equals to 3025 minus U squared plus 65. And therefore, UV is equal to something. And then we round it to 2 decimal places. What I'm going to say is solve. We can just get a pair of equations. That expression is equal to f of x minus 0, x minus 500, comma, y equals to f of x, comma, xy. And then you get these two values. So 12.99748 dot dot dot, and 118.44, 216, 93, etc. So it's approximately equal to, now be aware of the rounding. If you round that up, you should get 13.00, and not much problem with the rounding here. It's 118.44, 2 decimal places, okay? The next thing you want to do is, well, find alpha in degrees corrected to decimal places. So basically, you need to recognize the gradient of P2B equals to tangent pi minus alpha, okay? Because this is a line with a negative gradient, negative slope. So this angle is pi minus alpha. And then we can just get, for example, sub this value x into the gradient function, you get a minus 0.243, and then we use the solve button. Because you want to find the angle in degrees, you say tangent, instead of using pi, I should say 180, okay, 180 degrees. I'm not going to change to degree mode. Instead, I just say 180 degrees minus alpha degrees equals to minus 0.243, dot, 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 okay? And the alpha is approximately equal to some angle here. So I use the solve button, tangent 180 degrees minus a degrees equals to that expression for a. Given that a is between 0 and 180. 13.6693, dot, 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 rounded to 13.67 degrees, okay? And then finally, hence or otherwise, find the length of time to the nearest minute during which the bolt at B is visible. So previous part, you probably notice if you draw a line connecting the B and the C. This was your P1, okay? The start where the bolt, starts to be visible. And previously we calculated the theta here, right? Theta is approximately 7.407 something. And you have this alpha angle here, 13.6693 something. So you might get, let's say, this is alpha minus theta. And this is a perpendicular tangent to the radius. And let's say this is a beta. So for example, you can use the right angle triangle to find the value of beta. And this angle beta corresponds to the arc here. Arc is part of the circle. A whole circle corresponds to 360 degrees. And if you are able to figure out the ratio between the beta to 360, then you should be able to multiply a constant and then get the time, okay? From the diagram, the beta angle equals to 90 degrees. 180, knock out the 90 degrees. Remaining 90 degrees, subtracting alpha minus theta. That gives you some value. Use a large value here, minus the previous angle. You should get like 83.73759 something, okay, degrees. Using the ratio, the time t required divided by 30 minutes equals to 83.73759 divided by 360 degrees, okay? Therefore, t equals to 83.73759 divided by 360 times 30. And we round that value correct to the nearest minute. So that divided by 360 times 30. 6.978, which is rounded to 7 minutes. Okay. There is an alternative method, but it's a bit cumbersome. First, you have to find, let's say, the equation of this line CB and intersecting the circle here, but you have to use the full circle. And then you get the y value here. I'm going to show you. So let's say YCB is assigned to the gradient 65 over 500, but it's a negative gradient, okay? Negative gradient times x minus 500. Okay, so this is the first equation. And then the circle equation, we can recover that. But what I need to find is like x squared plus y minus 65 squared equals to 55 squared. And y equals to ycb, comma xy. And I can find, let's say, just these coordinates. So we want x greater than 0. So you will get x equals to 54.54 and y equals to 57.909 something, okay? And then you can solve this equation because the y value is just the height of the Ferris wheel capsule above the ground. You say h of t equals to this y value here for t, and it should occur in the first half of the cycle, so 0 to 15. So you get the first t value here. And then just use the same command here, but use your part F. Part F, you have this y value for the location, y value of the P2. So you go back and grab this value here, and you should be able to get a 13.86 or 89, etc. Now take the time difference. It's the same value as obtained before, 6.978, okay? So quickly outline the solution here. Intersection between line CD and a circle. So y equals to, for example, so HT1 equals to 57.90966. Between 0 and 15, you get a T1 equals to, let's say, 6.8827. Use part F again. We say HT2 equals to 118.44216. And this T2 is also between 0 and 15. So you get T2 equals to 13.86 089. Therefore, feasible time along the circle, along the wheel, is delta t equals to T2 minus T1, which is rounded to 7 minutes. I think that's the otherwise approach, okay? Otherwise approach, but you can see it takes more steps. So just be very careful if you apply any other alternative method, okay? Okay, so now we have 2 more extended response questions to go. So let's have a look at the next one. Okay, question 3, 90 marks. The time Jennifer spends on her homework each day varies, but she does some homework every day. The continuous random variable t, which models the time that Jennifer spends each day on her homework, as a probability function, like a linear function, and a 0. So just be mindful. The first thing I'm going to draw, if I want to sketch the graph of f, is before 20, that's a 0. After 70, that's a 0. So I'm going to clearly draw, let's say, 0, horizontal line, okay? This is 20, 0, and this is 70, 0. Okay, another thing is when you sub in, for example, 45 or 45 here. If you sub the 45 into either here or here, you get 1 out of 25. So 45, 1 out of 25 is here, okay? So you'll be able to get something like this, a straight line. And also the other part is another straight line, okay? So in actual fact, this 3-mark expression was very straightforward. And you can see the graph is continuous everywhere. Now, to find out, let's say the specific probability values, I probably need to define the function, okay? I'll define the function. Control up, menu, insert problem, and I'll carefully look at, let's say, the definition. So I'll say f of t is assigned to hybrid function, piecewise function. The first piece is 1 out of 625 times t minus 20 for 20 less than or equal to t less than 45. Next entry, 1 out of 625 times 70 minus t between 45 less than or equal to t less than or equal to 70. And a 0 is just elsewhere, okay? And then you say, okay, I would like the probability between 25 and 55, f of t dt. So you get 4 over 5. Next thing is, if t is less than or equal to 25, given that t is less than or equal to 55, I probably would say you need to calculate, for example, a 25 up back to 20 divided by an integral from 55 to 20. Should be able to get some answer like that, okay? It's an exact value. You don't want to write, let's say, some decimal approximations, okay? Yep. So it's 25 to 55 f of t dt equals to 4 over 5, exactly. And then for the conditional probability, it's equal to probability of t less than or equal to 25 divided by probability of t less than or equal to 55. But you know, anything before 20 does not generate any area under the curve. So you have to use 20 to 25 f of t dt divided by 20 to 55 ft dt. Okay? So actually get a 1 out of 41. That's the final answer. What kind of value does this give me? I'll press Control Enter. Okay. So you can see, you could also say, it's not recommended, but you could say 0.024390, 24390. So it's a recurring decimal, but it's very rare. Well, if you can write, let's say, a fraction answer, well, just write a fraction answer, okay? Okay, find a such that probability t greater than or equal to a is 0.7. So you need to use 8 up to, let's have a look, 70. 70, okay? From a to 70, f of t dt equals to 0.7. Or you can say 20 to a ft dt equals to 0.3, etc. Set out the correct equation and then just solve for a. In this case, I'm going to use, let's say a to 20 to a f of t dt equals to 0.3 for a, correct to 4 decimal places. So this is one possible answer. If you get, let's say, from A to 70, that's a 0.7. Oh, it takes a while, but yeah, you should be able to get that. So if your calculator is frozen, well, you probably need to recognize, okay, just change it the other direction and solve the definite integral equation. Like, from 20 to 45, that's half probability. 45 to 70, that's half. So try to use the number less than half and then use the correct side. Or maybe you can just go for the explicit expression if it doesn't work for you. Solve shift plus from 20 to A, and then just the explicit expression equal to 0.3, comma A. But in this case, you get two answers. You need to select the one larger than 20, okay? Yeah, along this line, okay? Okay. The probability that Jennifer spends more than 50 minutes on her homework on any given day is 8 over 25. Assume that the amount of time spent on her homework on any day is independent of the time spent on her homework on any other day. Find the probability that Jennifer spends more than 50 minutes on homework on more than 3 of 7 randomly chosen days, correct to 4 decimal places. So I can say this is a probability distribution X. It's a binomial 7. It's either more than or less than or equal to. And more than 3, that means probability X greater than 3. And if I involve an equal sign for this discrete probability distribution, that's from 4 to 7, okay? So I'm going to use binom CDF 7, 8 over 25, comma, 4 to 7. The answer is 0.1534, if I'm not mistaken. 4 decimal places. 4 decimal places. Find the probability that Jennifer spent more than 50 minutes on her homework on at least 2 of the 7 randomly chosen days, given that she spent more than 50 minutes on her homework on at least one of those days. So we would like X greater than or equal to 2, given that X greater than or equal to 1. Recognizing the conditional statement, it's probability X greater than or equal to 2 divided by X greater than or equal to 1. The probability 2 is here, 1 is here, divide them through. Should get the answer. It's 0.7626 because the 7 here needs to be rounded up. Okay. Okay, so that's part E. And let B be the probability that on any given day, Jennifer spent more than D minutes on her homework. So probability time T greater than D equals to P. This is the key step to understand what's happening next. Q be the probability that on 2 or 3 days out of 7 randomly chosen days, she spent more than D minutes on her homework. Now this is another binomial distribution. We call it Y. Still 7 days, but now the P is unknown, okay? Express Q as a polynomial in terms of P. So we need this Y equal to 2 or 3. So Q equals to probability of Y equals to 2 plus probability of Y equals to 3. This question involved 2 marks. What I will do is, I know this is like 7 choose 2, P squared, 1 minus P to the power 5 plus 7 choose 3, p to the power 3, 1 minus p to the power 4. But if you don't evaluate, let's say 7 choose 2, 7 choose 3, that's not enough in my opinion because they are not simplified numbers. So what you might do is NCR bracket 7, 2 times p to the power 2 times 1 minus p to the power 5 plus NCR 7 choose 3 times p to the power of 3 times 1 minus p to the power 4. So you'll be able to get some expression like that. Okay, we call it Q. Q of P is given by this thing. Next part, we want to find the maximum value of Q and the value of Q for which the maximum occurs. Just notice, before I proceed, I'll write this down. 7 power P power 2, P minus 1 to the power 4, and a 2P plus 3. Okay. For this function, I believe the p-value should lie between 0 and 1 because that's a proportion of probability. We need to maximize this expression over 0 to 1. That's why I'll say f max q of p, p, 0 to 1. You get that exact value, and it's rounded to 4 decimal places. And then for the maximum value, I'll get this maximum value of q, okay? The exact value is p equals to root 30 minus 3 divided by 7, which is rounded to 0.3539. And the Q maximum is going to be 0.5664667. And it's rounded to 0.5665. Okay. And I find the value of D for which the maximum found in part G1 occurs correct to the nearest minute. So basically, I need to relate the p-value here back to the probability statement. In this case, I'm going to get a D to 70. F of t dt equals to 0.353 889, etc., etc. Okay. So use all digits to avoid any rounding error. And then solve for D. My D is approximately equal to something. So just go back and grab, let's say, any equation solving like that. This is from D to 70, and it's equal to this p-value. Or actually, I can use the exact value. That's more convenient for D. Control Enter. This is my laptop. It's very quick. If it's on your handheld, you might want to wait for, let's say, 10 seconds, 20 seconds, etc. Okay? So it's 48.9676. So therefore, correct to the nearest minute, you get a 49 minutes. Okay? Okay, so the whole probability question is done. Then we have a look at the last extended response question. Continue over page. Okay, f of x is 2 to the power x plus 1 minus 2. Part of the graph of x is shown below. So immediately I could identify this is y equals to minus 2 as a horizontal asymptote. It's cutting through 0, 0. Now the transformation here, in the current study design, you probably would just see, okay, t xy equals to x plus c, comma, y plus d. And the transformation maps the graph y equals to 2 to the power x onto the graph of f, state the values of c and d. So you can see it's like a 1 unit to the left and 2 units down. So c value is going to be minus 1. D is minus 2, okay? You might want to do it in this way. Say the old graph is y equals to 2 to the power x. The new graph is y1 equals to 2 to the power x1 plus 1 minus 2. So eventually what you might see is, okay, yeah, you could just say y1 plus 2 equals to 2x1 plus 1. So x1 plus 1 equals to x, y1 plus 2 equals to y. Therefore, you get x1 equals to x minus 1, y1 equals to y minus 2. And that's why this bit is your x1, this bit is your y1, all right? So you say C value is minus 1, D value is minus 2. Okay, find the rule and domain for f inverse, the inverse function of f, and find the area bounded by the graph of f and f inverse. Notice that this graph was not drawn to the perfect scale. The vertical direction is a bit flattened. I'll press Ctrl up, define the function. F of x is assigned to 2 to the power of x plus 1 minus 2. If I want to find a rule and a domain, x equals to f of y, comma y, and the domain is x greater than minus 2. Now, if I want to find the area between the two curves, I probably will get f of x sketched first and then grab this bit. And taking a closer look, zoom in a little bit. You will identify their intersection is at minus 1, minus 1, okay? So from minus 1 to 1 and do the integration. Alternatively, you could also write this expression in other equivalent notations. For example, if I grab it here, I press menu, algebra, A, convert expression, convert to log base 2. This is due to the change of base formula, all right? You can also write your inverse function in that way. And then if I want to calculate the area, just notice the red is above, the blue is below, from minus 1 to 0. So you can go from minus 1 to 0 and the f inverse subtracting f of x dx. So you get some expression like that. Other expressions will be equivalent, okay? Other expressions will be equivalent. For example, you might want to do 2 lots of x minus that. You also get that equivalent expression, okay? And this is 2 over natural log 2, which is identical to 3 minus 2 log 2 of e, okay? Something along these lines. Because the question wanted the domain, you can write the full function notation and put the correct domain in the first bit. Okay, or you can state them separately, like state them separately. You can use ln as long as it's suitable, okay? But if you write ln, is the ratio between two natural logs, okay? For the area bounded by the curves, I say, okay, fx equals to f inverse of x when x equals to minus 1, x equals to 0. So the area equals to minus 1 to 0, f inverse of x minus f of x dx. Or 2 lots of minus 1 to 0, x minus f of x dx. Or 2 lots of minus 1, 0, we say f inverse of x, take away x using the symmetry. I'll just put them here for your future reference, and the answer can be expressed as 3 minus 2 log 2 of e, or 3 take away 2 divided by log e of 2, or some calculator, like I need to express that as a natural log, depending on what entry you put, what kind of function you put, okay? So these are equivalent method or equivalent answers, okay? All right. Part of the graphs of A and F inverse, you can see, okay, this is like minus 1, minus 1. We want to find a gradient of F and a gradient of F inverse at x equals to 0. So you might say, derivative f of x comma x given x equals to 0. And if I use the second function, that's f2, my inverse, that's 1 over 2 natural log 2. We say f dash of 0 equals to 2 natural log 2. Or if you wish, you can say natural log 4, etc. F inverse, we say F inverse, we put a bracket around it, put a dash here, 0. That is 1 over 2 natural log 2, okay? I believe it's 1 mark for each. Very easy calculator application. Okay, we have a function g to the gk. K is r plus, defined with the domain r such that gkx is 2ekx minus 2. We want to find the value of k such that gkx equals to f of x. And the final rule for the inverse function, gk inverse of gk. K is also positive. So define gk of x equal to 2 exponential k times x minus 2. Okay? And then solve gk of x equals to f of x for k. K is natural log 2. Exact value only, okay? And find the rule. It doesn't ask for the domain. So we just say solve x equals to gk of y, comma y. And that is my new function. So just say gk minus 1 of x equals to 1 over k log e x plus 2 divided by 2. X is greater than minus 2. Okay? All right, move on. Describe the transformation that maps the graph G1 onto GK. Well, this subscript 1 means K equals to 1. So G1 of X is 2EX minus 2. And the GK of X equals to 2EK times X minus 2. We recognize this is GKX equals to G1 of KX. So it's a dilation factor of 1 over K from the vertical or from the y-axis. You might want to say parallel to the x-axis, okay? And describe the transformation that maps the graph of G1 inverse. So G1 inverse of x is log e of x plus 2 divided by 2. And the gk inverse of x is 1 over k log e x plus 2 divided by 2. So you can see the whole function is multiplied by 1 over k. Therefore, we say gkx equals to 1 over k. I'll put the inverse here. G1 inverse x is a dilation factor of 1 over k from the x-axis. Or you say from the horizontal axis, okay? From the vertical axis, that's the horizontal dilation. From the x-axis, that is the vertical dilation. All right, this question was proven to be challenging for many students. The lines L1 and L2 are the tangents at the origin to the graph GK and the GK inverse respectively. Find the values of a K for which the angle between L1 and L2 is 30 degrees. So basically, the gradient of gradient 1 is GK dash 0. Gradient 2 equals to GK inverse dash 0. So we can find the gradients. Just get a list here. Take the derivative with respect to x, gk of x, and this expression, given x equals to 0, you actually get, let's say, 2k and 1 over 2k. But which one is larger? You might get, for example, this one could be larger, this one could be smaller gradient. Well, we could get, let's say, that equals to tangent alpha, that equals to tangent beta, okay? So actually I get alpha equals to tangent inverse of 2k. That would give me beta equals to tangent inverse 1 over 2k. If alpha is greater than beta, then we have tangent inverse of 2k subtracting tangent inverse of 1 over 2k equals to pi on 6, 30 degrees, okay? If beta is greater than alpha, we have tangent inverse of 1 over 2k subtracting tangent inverse of 2k equals to 30 degrees. I'm going to solve them respectively. So if I solve arctangent 2k minus arctangent 1 over 2k equals to pi on 6. Okay. You don't actually get this solved immediately because it doesn't spit out, let's say, exact solution. So if you try Control Enter, you get this value here. Ignore the minus. Okay, ignore the minus. You can only get that. But the question wants, let's say, the question didn't say rounded to some decimal places. So what I'll do is I'll grab everything, delete, and try to get the bottom exact. It does give me, let's say, some nice value, and I definitely don't want to copy everything there. But I believe if it's something relevant to pi on 6, you might think tangent pi on 6 is 1 over root 3 something. So it may have something to do with, let's say, a third or square root, okay? So what I may do here is once I grabbed all the digits from the decimal output, if the answer is indeed related to a square root, you square it first. You can get, oh, if I square everything here, it's 0.75. Then I take a square root of this number. Maybe I should get rid of the 5 here. It's negligible. It's root 3 on 2, okay? Root 3 on 2. So that's one possible value. The other case, I'll replicate the process like here, but I just put a minus pi on 6. Control Enter, you get this value. So probably we'll just get a k greater than 0. Control Enter, and highlight everything. Square it. If you square it, it's like 0.0833333. Well, what kind of value do I get from that? We can use menu number approximate to fraction. 1 out of 12. Just ignore the 0 and ignore the 0, 0, zeros, and 1s. So I'm going to get, for example, 0.083 recurring. That is 1 out of 12. And I just take a square root of 1 out of 12. So the answer is either 1 over 2 root 3 or root 3 over 6. Okay, so that is indeed a challenging question, unless you use some kind of, double angle formula, etc., or compound angle formula. To be honest with you, you could also use this formula. I'll put it as a separate note here. Tangent alpha minus beta equals to tangent alpha take away tangent beta divided by 1 minus 1 plus tangent alpha tangent beta. This is part of the specialist math knowledge, okay? Some trigonometric identities. Now, if you recognize tangent alpha, tangent beta, you can represent them as 2k and 1 over 2k. You say 2k minus 1 over 2k divided by 1 plus 2k times 1 over 2k equals to tangent 30 degrees, okay? If you are going to use that to explicitly express the equation in terms of k, you may get, let's say, 2k minus 1 over 2k, 1 plus 2k times 1 over 2k is 1 equals to tangent 30 degrees. Okay, then you get the exact value. Or if you put a minus 30 here, you get the other exact value. Okay. Okay, so that is something you might want to use here. All right. Finally, let P be the value of K for which GKX equals to G inverse. GK inverse X has only one solution. Find P. You could actually get these two graphs sketched. GK of X is this guy, and the inverse, if I go back, it's this guy. I'll put a K1 here, and I'll also put a K1 here. Now, I'll grab, let's say, the inverse function, insert a slider for K1, and I'll also grab this graph. Okay, so if you want them to touch each other, change the setting, step size, 0.05. See what's happening. So if you get k equals to 0.5, they could touch each other, okay? With a common tangent at y equals to x. So you might say, okay, gk dash at 0 equals to 1. Common tangent at x equals to 0 along y equals to x, okay? Then we say, okay, we found gk dash 0 before, so it was 2k. So we have 2k equals to 1 and a k equals to half. Alternatively, you might want to draw some sliders, okay? Draw some sliders. K equals to half. Touch each other. Something along this line. Okay, last part. Let AK be the area bounded by the graph of GK and GK inverse for all k greater than P. State the smallest value of B such that AK is less than B. So you need to observe from the slider. That's the most straightforward method. I'll put a 1 here. I'll put a 1 here. Actually, if you push the k value larger and larger, you can see the area bounded between the graph is like a balloon, okay? It's like a balloon. Initially, it was very flat, no bounded area at all. Now, if I change this value to 100, etc., once I increase the k value, you can see we always blow a balloon, but the balloon has the area bounded by the horizontal asymptote here and the vertical asymptote here. So it's eventually the balloon is bounded by a square. 2 times 2 is 4. So the answer is 4, okay? So that is my answer to the last part. Okay, I'm going to stop here and find the other time to do the multi-choice questions. See you later.